All right, day 5. Moving on to the frequency and the period of a trig graph. So let's first start off by graphing this one here, f of x equals cosine x. This is our parent function for cosine. So it starts high, 0, low, 0, high, and then it repeats that pattern over here on the other side. And yes, I would like you to be able to eventually get that quick with drawing your parent function. So, again, I'm going to write up here. Pattern. High, 0, low, 0, 5. Okay. Moving on to our next one. Our g of x equals the cosine of 1/2 x. So what's going to end up happening with this one when it's the cosine of 1/2 x? Because this was 1x, this is 1/2 x, that means I only want to get half of the cosine curve in this period here that we have here. So it's still going to follow the high 0, low 0, high, only it's going to take longer in order for it to get there. So 0 degrees, that's still going to be my high, only instead of 90 being my 0, it's going to stretch out to be pi. And then this would be my 2 pi. And that's how I'm going to get half of the curve in one period there. And so then over here, 0, -1. So that is our g of x. So 1/2 x means you want to get half of the curve in there in the same amount of time it took for a normal 1 curve to get in there. So then this one here, cosine of 2x, means I need to get 2 cosine curves in, whereas I would normally get 1 in. So normally it would take me till 2 pi to get 1 cosine curve in there. I need to get 1 full cosine curve in there by the time I get to pi now. So that means my 45s are going to come back into play. So it's still going to follow the 0 or the high, 0, low, 0, high, 0, low, 0, high. So now we get 2 cosine curves in there by the time I normally would have done only 1. And then it would repeat over here in the negatives. And that is our h of x. So that number in with x, that tells you how many times you got to get that curve in the period. And that is what we refer to as our b value. B represents our frequency. That answers the questions of how many cycles can be completed. Oops, I didn't want that there. How many cycles can be completed in the typical 0 to 2 pi period? That is kind of what we call our standard period. That's the period that we have for our parent functions, cosine, sine, tangent. Standard period is 0 to 2 pi. So frequency, that b value, which is in front of your x, tells you how many cycles happen from 0 to 2 pi. So then our period, that answers the question of how long does it take to complete 1 cycle. And we figure that out using that expression right there of 2 pi over b. Because again, 2 pi, that is our standard period, as you see over here, 0 to 2 pi. So you're dividing it by the frequency to see how long will it take for that equation to complete one of its full cycles. And then once we figure that out, we can then figure out our key points for spacing. Remember I talked about key points for your parent functions was 0, pi over 2 pi, 3 pi over 2, 2 pi. So key points, if your period ends up changing, those also end up changing. So we figure out our key points by taking your period and dividing it by 4, because there's always 4 points. So let's take a look at our graph here. So 3 sine 1/2 x. We need to find frequency, period, and our key points. Well, just to review, I'm still going to start off with amplitude because you can't go wrong with stating amplitude. Frequency, which is our b, that is the value in front of x. So our frequency here is 1/2. So that means in the standard time period of 0 to 2 pi, half of the curve is going to be drawn, kind of like our g of x that we had up above. The period here, again, we use the expression 2 pi over b. So in this case, it's going to be 2 pi over 1/2. Excuse me. So to get rid of our 1/2, I got to flip and multiply. So 2 pi times 2 ends up being 4 pi. So our period is 4 pi. So what that means is from 0 to 4 pi is how long it'll take to get one complete cosine curve, or I'm sorry, one complete sine curve with this one. And then our key points, which I'm going to shorten to be just KP, 4 pi divided by 4. Our key points are going to happen every pi. So, looking up here, standard pi over 2, pi, 3 pi over 2, 2 pi. What this key points of pi says is it's going to be 0, pi, 2 pi, 3 pi, 4 pi. That's where all the important points are going to end up hitting, is every pi value, as opposed to every pi over 2, which our standard graph was doing. And our range, just because we can't review it enough, I know it didn't ask for range, but our range here would be negative amplitude to positive amplitude, so -3 to +3. All right, let's do this again for number 2. Again, we're still going to review amplitude. So amplitude here is a 2. Our b value here is a 4, because that's the value in front of x. Even though it didn't ask for it, I'm going to do my range, which would be -2 to 2. And again, we have brackets because it includes the -2 and the +2. Remember, parentheses don't. Period, 2 pi over b. So that would reduce to pi over 2. So that means one complete cosine curve is going to happen by the time you get to pi over 2, which is 90. So you get one complete cosine curve. Looking at my graph, that means from here to here, you have one complete cosine curve in there. So then our key points, pi over 2 divided by 4. Again, you're kind of following the rules of fractions, because we can say that this is really 4 over 1. So dividing fractions, keep, change, flip, multiply across. Your key points are going to be happening every pi over 8. All right, taking a look at number 3 here. Amplitude 5. Frequency would be pi over 12, because that's what's in front of your x this time. Range, -5 to +5. Period, 2 pi over 12. So again, fraction rules, 2 pi is really over 1. Keep, change, flip. Pi's cancel, so our period here is 24. And remember, that would be radians, so 24 radians is what our period is. Key points, 24 divided by 4. Our key points would be every 6. So that's kind of an example of what you would see something during a word problem, which we'll talk about more also in a couple days. All right, 4, amplitude 12. Frequency 2 pi over 365. Range, -12 to +12. Period, 2 pi over 2 pi over 365. Do your keep change flip. Be 365. Key points would be 365 over 4, which if you divided, you would get a decimal, and you can do, but I'm going to leave it as the fraction because, as you remember, I personally love fractions. So, let's keep playing around with that frequency and period. So, frequency and period. Nope. This is what I want my third page to be. Nope. I had it right the first time. Let's do some graphs using our new frequency periods and then key points that we had. So 5, we're going to graph f of x equals 3 sine 1/2 x from negative 2 pi to 2 pi, which is the graph that I have here for you. So I am going to start making myself a list of what I know. Amplitude is 3, period is 1, or frequency is 1/2. Range would be negative 3 to positive 3. So that would mean I'd have to go by ones on my graph. If I go and I label my y-axis negative 3 to positive 3. Period 2 pi over 1/2. Keep change flip means that our period is 4 pi. So it would take us all the way to 4 pi and before we can actually figure, like, get an entire curve in there. Key points, 4 pi over 4 gives me a pi, so that means my key points are happening every pi. So, for my sine curve, my pattern is 0, high, 0, low, 0. I don't have a negative in front, so it's going to keep that pattern. It's going to stay 0, high, 0, low, 0. But because my key points are every pi, that means this is going to happen at 0. My high point is going to happen at pi. This is going to happen at 2 pi. If I continued on, that would be at 3 pi and 4 pi. I'm not continuing on. I'm stopping at 2 pi. So I'm only going to get 0, pi, 0, from 0 to positive 2 pi. And then if I were to continue my sine curve over here in the negatives, this would have to go down to negative 3 and then back up to 0. So there is our graph of 3 sine 1/2 x. So again, instead of the standard 2 pi over 2 pi, 3 pi over 2, this happened every pi. Let's try another one. We are going with cosine this time. They want us to graph from negative pi to 2 pi. So I highlight those two values so you know we're going to stop at negative pi, but we're going to go all the way up to 2 pi. So I'll start writing my information I know for my equation. My amplitude is 4, which means my range goes from negative 4 to positive 4. So on my y-axis, I have to go up by ones there. Okay. Other thing we know, frequency is a 2. So my period of 2 pi over 2 ends up being pi. So that means, because my period is pi, that means one entire cosine curve is going to happen from 0 to pi. Key points, pi over 4, which those are the 45s in radian measure. Pi over 4 is the 45s in radians. So, let's see here. My pattern for cosine, high, 0, 0, high. High, 0, low, 0, high. So key points are every pi over 4. So that's going to be at 0, This would be at pi over 4. This would be at pi over 2, 3 pi over 4, and then that would happen at pi. So again, I got to go up to 4. 45 is halfway. My low, 0, pi. And then I would keep following that pattern until I get to 2 pi. And for this one, until I get to negative pi. So with 1 curve, 2 curves, 3 total curves on this graph, but 2 complete curves from 0 to 2 pi. Okay. So more with, I just confused myself. All right, more with frequency and period. They are inversely related. So as one goes up, the other one goes down, and then vice versa. As the first one goes down, the other one goes up. So, because period equals 2 pi over b, and remember b is your frequency, we could also say that period times frequency has to equal 2 pi. So that's why they are inversely related. Inverse relations you should have talked about back in Algebra 1. You multiply the two of them together, it's always going to equal the same constant. No matter what two values you're multiplying, it's always going to be the same constant. So if we take a look at our examples here, determine the period of each of the following sinusoidal functions. Express your answers in exact form. So here we have a frequency of 4. Remember, frequency is our b. Period would be 2 pi over 4, which reduces to pi over 2. For letter B, frequency is pi over 3. Period would be 2 pi over pi over 3, which again, it would be 2 pi over 1 times 3 over pi. You end up with a 6. And then C, frequency is 2/3. Period would be 2 pi divided by 2/3. 2 pi over 1 times 3 over 2, which ends up giving you a period of 3 pi. So what is true about the product of the period and the frequency? Write an equation of the relationship. So for this first one, frequency times the period, if you multiply those out, you'd get 4 pi over 2, which is 2 pi. Here, if we multiply them out, you end up with 6 pi over 3, which is 2 pi. Last one, if we multiply them out, 2/3 times 3 pi, 6 pi over 3, which is 2 pi. So no matter what frequency and period you have, when you multiply them together, you're always going to get 2 pi. So that is why it's an inverse relationship. As one goes up, the other one has to go down. Okay. 4, describe the differences between the graphs y equals cosine of x and y equals cosine of 2x. And our third one, 1/2 x. So, this one being our parent function, I'll say a over here, 1 cycle, 0 to 2 pi. Remember, that is our standard one. So then b, because we have a frequency of 2, that means we have 2 cycles from 0 to 2 pi. You're going to get 2 cosine curves from 0 to 2 pi. So our last one, c, is 1/2 for our frequency. So that's going to be half a cycle, 0 to 2 pi. So those are going to be the differences. So our first one, parent function, you get 1 full cycle from 0 to 2 pi. Second one's got a frequency of 2, so that's 2 cycles from 0 to 2 pi, so that's 2 complete cosine curves. and then c is half of the cycle from 0 to 2 pi. So 5, we're going to sketch the function 2 sine 4x on the grid below for one full period to the left and right of the y-axis. Label the scale on your axis. So if you notice, this time I took that scale off because we are going to label it using our key points that we figure out. So amplitude is 2. So that means our range is -2 to +2. So because I can, I'm going to spread that graph out and do every other one as a 1. My frequency is a 4. So that means my period ends up being pi over 2. So by the time I get to 90 degrees, I need to have one complete sine curve drawn. So then the last part, my key point, pi over 2 divided by 4 would be pi over 8. So that means this is pi over 8. This would be 2 pi over 8, which reduces to pi over 4. 3 pi over 8. 4 pi over 8, which would be pi over 2. That would complete one full cycle. So we put all 4 key points on there. And then we do it going in the negative direction also. So I don't want 2 pi. Pi over 2. So again, the reason why these aren't all over 8 is because these two here, this one and this one, those reduced down to be pi over 4 and pi over 2. But this would be, 2 pi over 8, 4 pi over 8. So you got 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8. And then they just keep repeating that over and over and over again. So sine curves pattern, 0, high, 0, low, 0. There's one complete cycle to the right of your y-axis. And then I'm going to mimic the cycle over here on the left of my y-axis. Get a little more accurate there, Palky. There you go. So there's your one full period to the left and to the right of your y-axis. So sometimes you do need to change the labels on your y-axis also depending on what your key points are. So the heights of the tides can be described using a sinusoidal model of the form here, y equals a cosine bx plus c, because tides, if you think about it, high tides, low tides, they follow a periodic function, because you have high tide, and then you go to low tide, and then you go back to high tide, and then you go back to low tide, high tide, low tide, high tide, low tide, da, da, da. So it creates a sinusoidal function, as we call it. So if high tides are separated by 24 hours, so from high tide to high tide is 24 hours. That means our period is 24 hours. It takes 24 hours for it to complete one full cycle. So that is our period. Which of the following gives the frequency of the curve? Well, since period is the formula 2 pi over b, we set it equal to 24 because that's what I know. I know my period is 24. Multiply both sides by b. Divide by 24. And we end up with pi over 12 is our frequency. So looking at some more transformations on our functions here than just the amplitude, period, and frequency that we have been dealing with. The last part of our transformations are the phase shifts. So the phase shifts are exactly the same. If you notice, c is inside the parentheses. So x plus c would go to the left. X minus c would go to the right, just like it does for every other function. Like if you have x minus 3 squared, that means my graph is going to the right 3. If I change it to x plus 3 squared, my graph is going to the left 3. Vertical shift, positive is up, negative is down. Again, that is exactly the same. Midline is the average of the range. And it's an equation, y equals d. D is max plus min divided by 2. You take the average of your max, average of your min, divide by 2. Now, if you do have a vertical shift up or down, it does affect your range. So it would be your negative amplitude plus whatever d is at the end, and then positive amplitude plus that same d value. You would add those to it. Now, if it were a negative, you'd add a negative to them. If d is positive, you just add positive to it. So we're going to find amplitude, frequency, period, phase shift, vertical shift, midline, and range for all of these functions here. And of course, I'm going to add a couple of other things in too, just to keep practicing them. So amplitude is 3, period is 2. This time period is out in front of the parentheses because we also have a phase shift in there. Period, 2 pi over 2, so our period is pi. If we had to draw the graph of it, that means our key points are happening every pi over 4, so every 45 degrees. So then we have a phase shift. I'm going to shorten that to PS because I don't feel like writing the whole thing. We have a phase shift right in here. If it's minus 90, that means it's to the right 90. So your whole graph, so let's say this is our graph, that would all shift to the right 90. So it would be the same shape, it's just everything is moved over 90 degrees to the right. Vertical shift would be up 3. So therefore, our midline would be at y equals 3. We didn't talk too much about the midline yet. Typically, all of the graphs we have done so far, your midline has been at 0, which is your x-axis. But now your midline can change, and it's not always going to be your x-axis. And then our last one, range. Using my amplitude, it would be negative 3 to 3, but because I have a phase shift up 3, I'm going to add that. So negative 3 plus 3 is 0. 3 plus 3 is 6. So my range now is going to be 0 to 6. And we will take a look what these all look like on the graph in a minute. We're just going to practice and continue to practice right now finding it from the equation. So let's try it, excuse me, again. So our amplitude is 1. We got that negative sign there, but that doesn't affect the amplitude. Remember, the amplitude is always a positive. My B value is a 1 right there in front of the parentheses. Again, there's nothing there, so that means it's a 1. So my period would be 2 pi over 1, so just simply 2 pi. So that means this is a standard period. Key points would be every pi over 2. Because if I did 2 pi divided by 4, it would simplify to pi over 2. We have a phase shift. Because it's plus, that means it'd be to the left, pi over 3. We also have it reflecting over the x-axis. That's what that negative sign out in front does. It reflects it over your x-axis. Vertical shift down 2, which means our midline would be at y equals negative 2. Whatever that number is, that's where your midline is. So my last one, my range. Again, if I didn't have a shift, it'd be negative 1, 1. But then I got to add my negative 2 to it. So my range would be negative 3 to negative 1. It's all been shifted down too. Excuse me. Third one, amplitude is 1/2. Frequency is pi over 6. Period would be 2 pi over 6, which ends up being 12. So then your key points would be every 3. Okay, phase shift. This would be right 45 degrees, which is pi over 4. Vertical shift of up 2, so therefore your midline is y equals a 2. So then my range, -1/2 to +1/2 plus my 2 plus my 2 gives me 3/2 to 5/2. All right, last one. Try to pause the video, see if you can fill in the list. I don't expect you to memorize what the list is, but see if you can find your A, your B, your period, and all that stuff. So pause. All right, take a moment, see how you did. Hopefully you did well. This one did have the extra reflect over the x-axis, like number 2 did. Okay. Excuse me again. So the graph of f of x equals sine x becomes the graph of g of x equals cosine x with what transformation? So, let's take a look at this. Here is y equals sine x. Let me pick a different color. That one will be good. So here is cosine x, but if I continue my cosine x, g of x, so we don't get confused here, let me label that. Pink is f of x. Good. So g of x. If I continue this down, now this looks like my sine curve, but all that's happened is my sine curve has moved to the left 90 degrees. So we could say left, oh my God, I don't know why it keeps doing that to me, pi over 2. That would be the transformation. If I took my sine curve and I shifted it left pi over 2, then it would turn into my cosine curve. And yeah, everybody realizes that they look pretty much identical except for that little phase shift. All right, 2 more. Let's try some graphs using all of the pieces of information that we know. And it's going to be making that list that we were just practicing on the other page. My amplitude here is 2. My frequency is 1, which means my period is 2 pi. So I'm going to get one complete sine curve in by the time I get to 2 pi. So my key points are happening every pi over 2, which again, that is standard. So we don't have a phase shift. There's nothing here with x. However, we are reflected over the x-axis because it is negative out in front. There is a vertical shift up 1, so that means our midline is at y equals 1. So our midline, when it gets shifted, we show that as a dotted line. And then the last thing we need to know is our range. So that would be -2 to 2, but plus our up 1. So -1 to 3. So again, the midline shifts everything up. The other thing to pay attention to is we're only graphing from 0 to 2 pi. So we're only graphing over here on the right side of that x, or of that y-axis. So because we have the reflect, that means my pattern is going to be 0, low, 0, high, 0. It's going to flip. So because the midline shifted, our zeros here means the midline. The midline is viewed as being your 0 at this point in time. So when the midline moves up, that means your 0 technically moves up as well. So we're going to go 0 from my midline. I'm going to go down 2 since I had an amplitude of 2, 0, up to 0. And so there is our curve, y equals -2 sine x plus 1. Let's try one more. This time we're going to use our whole graph. It says from negative 2 pi to positive 2 pi, which is what we have here. That is our entire graph. So this time, cosine. So that means my pattern is going to be high, 0, low, 0, high. So now I'm going to go over here to my list. Amplitude is 3. B is a 1, which means my period is 2 pi. So my key points is pi over 2. So again, that is your standard graph. So that aspect is not going to change. Excuse me. We do have a phase shift, left pi. There's a vertical shift of down 2, which means my midline is at y equals negative 2. So I'm actually going to go and draw that in first. As soon as I figure out where my midline is, you always want to draw that in first before you try to do anything else with the curve. So there's my midline. Missing range. So negative 3 to 3, but minus my 2 means my range is going to be negative 5 to 1. Okay. So we have gone left pi. So this whole curve is going to shift to the left pi. So now normally, in my normal cosine curve, this would be 0. I'll use radians. Pi over 2, pi, 3 pi over 2, and then 2 pi. But everything's been shifted to the left pi. So it's been shifted to the left 180. So that means at pi, I'm going to be high. This would be 3 pi over 2. This would be my 2 pi. So my amplitude again is 3. So my high at pi is going to be there. And then it's going to come down to my midline. And it's going to go down here to negative 5. And again, we know the shape of the cosine curve. So this should go down here to 0, back to low, 0, high, 0, low. Now again, because we're used to seeing it start from 0, this looks like it's upside down and it's been reflected, but it hasn't. Everything, remember, got shifted over this way. So if I were to shift this back pi, which is really 2 spaces, I took this and I moved it over 2, it'd be exact same kind of cosine curve. So this all just got shifted to the left pi. So go try your homework, practice it. Let me know if you have questions.